Consider the curve with equation. We have the curve to be y is equals to 2x minus 1 into e power kx, where x is a real number and k is an integer. The tangent to the curve at a point x equals to 1 is parallel to this line. Find the value of k. So this means, let's say I have some random curve. Let's say the equation of this curve is y is equals to 2x minus 1 times e power kx. And we are talking about at x equals to 1. Let's say this is x equals to 1. There is a tangent, something like this. And the tangent to this curve at point 1. Now, this red line would be parallel to, there is another line which is y is equals to 5 e power kx. So that's, let's say, something like this. Let's say that's something like this line. Basically, this is the line which is y is equals to 5 into e power kx. Now, they have said that these two lines are parallel. Whenever two lines are parallel, they will have the same gradient. If you look at it, this is in the form of y equals to mx plus c, where c is 0. And the gradient of this line is 5 into e power k. So that is the reason. So the gradient of tangent will also be equals to 5 into e power k. So this is the most important point to note. Now, how do we find the gradient of tangent whenever the equation is given? So the gradient of tangent would be same as, so suppose if I talk about gradient of tangent at a point at x equals to a, or in this case at x equals to 1, will be same as dy by dx at x equals to 1. So which means in order to find the gradient of a tangent for this curve, we need to find the derivative and substitute x as 1. So when I talk about finding a derivative, so I have y is equals to 2x minus 1 into e power kx. And this is like a product of two. We have a product of two terms. We need to apply a product rule. So dy by dx would be equals to the derivative of first term. So the differentiation of 2x plus 1 would be differentiation of 2x is 2 minus differentiation of just a constant would be 0, because whenever you have a constant and a variable, we would always keep the constant as it is and we would differentiate the variable. So differentiation of x is just 1. But whenever you have a constant alone, we would differentiate a constant and the differentiation of a constant is 0. And we keep the second term as it is, that's the product rule, which is e power kx, plus we keep the first term as it is, and we would differentiate the second term. So differentiation of a second term would be e to the power of kx times k, because differentiation of e power anything would be e power the same thing, and using a chain rule, the differentiation of kx would be k. So now we know this. Let's say dy by dx at x equals to 1. So which means we have to put x as 1. So this is 2 minus 0, which is 2. And e to the power of k times 1, which would be just k. Plus, this is going to be 2 times 1 minus 1. And this is going to be e to the power of k times k. And we know this, the derivative at x equals to 1, that would represent the gradient of tangent at x equals to 1, which is same as 5 into e power k. So on the left-hand side, you can just write it as 5 into e power k. And here, if you take out e power k common out, you'll be left with 2 plus. This is going to be 2 minus 1, which is anyhow 1, 2 plus k into e power k. So both the sides you can cancel out e power k. So 5 is equals to 2 plus k. So that's why k is 5 minus 2, which is 3. And this is the right answer for the sum. The 5 marks distribution goes something like this. So 1 mark is for, of course, first of all, we need to show the derivative. So 1 mark is for showing that we are using the product rule. And the second mark is for the simplification. So basically, we will be getting 2 marks for this step. And the third mark is for substituting excess 1. So this step would carry a third mark. And the fourth mark is for finding the gradient and equating them. So that's basically finding a gradient of a tangent, this one, or equating them. So if even if you have mentioned this, that is the gradient of tangent is this, or if you have directly equated it, both would be the same thing. So then the final 1 mark is for showing that the value of k is 3. This is how the 5 marks are distributed for this sum.